Hey Vsauce, Tate here. Time. To talk about it. That was only 5 seconds, but it probably felt like an eternity to you. That's because time is relative. But then, how do we know what time it is? Well, one way is to watch. But, if you don't have one of those, you might use a clock instead. Tick, tock, tick, tock, every second. But what if instead your clock went tick, 4/10,000ths of a second, tick, 4/10,000ths of a second? The Foucault pendulum is a surprisingly interesting mechanic. Simply all it is a weight attached to a string that oscillates back and forth. And as it does throughout the course of a day, it rotates, beginning like this, then moving like this, and like this, and like this, until eventually it comes back to where it started, roughly modeling the actions of a clock or a sundial. Now, the interesting thing about Foucault's pendulum is that it doesn't matter how much weight or so much what is on the end of the string. A longer string is preferable to show the difference, but the actual mechanics come from the Earth's rotation and not from whatever load is on the end of the pendulum. What if we put these pendulum ideas to the test? I'm going to pull it back to right there in the painting, and then let it go. Interesting. What if we take it and we move it even further back? What then? Fascinating. But what if we made things a little heavier? Once again, we'll take it to the same spot and drop it. Fascinating. As you watch these slow motion replays of the 3 different swings, the one of the small band released from a smaller point, the one of the small band released from a higher point, and the wooden cutting board, all with different variables affecting them, you'll notice that they all swing within 5/1000ths of a second of each other. You might be asking, why is that? Well, it turns out the period of a pendulum is affected by 2 variables and 2 variables only: the length of the string and the gravitational constant. There are no other factors in this equation because the period of a pendulum is dependent on just the formula for the... There are no other factors in this calculus because the formula for the period of a pendulum, that is the time it takes to swing from where it was down to equilibrium and then back out to its point on the other side of equilibrium, and then all the way back to its initial starting point. That all is one period. Time it takes for it to complete that is equivalent to 2 pi times the square root of the length over gravitational constant. So since for most of us, we'll be living on Earth our whole life, since space travel is not widespread, that gravitational constant is going to be 10 meters per second squared for us. So really, the only factor affecting the period of a pendulum for most of our lives will be the length of the string. So the next time you're standing in front of a wrecking ball or just a pendulum on a clock, think to yourself, how long is that string? And how long does it take to swing? As always, thanks for watching.